As I said at the end of the last video, the main difference between what we saw before and what's called a rational equation is that we have x values in the denominator. So we are now dividing by x instead of taking x divided by some value, where the biggest difference between dealing with these and those is that here we have to avoid division by zero, because when you divide by zero in math, very, very bad things happen. We don't like it when very, very bad things happen, most of the time. Point is, you have a bit of a restriction there, a restriction on the domain, which is a hint at a thing that we'll talk about when we get to functions in a while, but for now, let's keep the algebra train going with another example. So for this, we want to solve the equation 1 over x equals 1 over 5 plus 3 over 2x. So here, like I said, we have to be careful with that potential x in the denominator, as it can cause a 0 in the denominator. So, to be sure, we don't want x to be equal to 0. In some regard, we would like to avoid that as much as possible. And then from there, because we have a whole bunch of divisions, we need to find a least common multiple again. So here, it's a little bit dicier because you don't have that single largest value to think in terms of. But we can think about the numbers first. So the biggest one's 5. If we multiply 5 by 2, you get 10. And hey, that's nice. That takes care of the 2. And you can put the x wherever you want, kind of. It's kind of the nice thing about those x's, as long as you don't have a whole bunch of them. So here, in this case, our least common multiple is not just a number, but it is, in particular, a variable value, 10x. So if we want to solve this equation, make sure it actually, works, what we can do is take our 1 over x along with our 1/5 and our 3 over 2x and toss in a 10x to both sides, just like before. Except we've got slightly funkier looking things that were thrown in there. But here, because we did the same thing on both sides, the x's cancel, so on the left, all we'll get there is 10. Meanwhile, over here, 10x goes into 1/5, gets rid of the 5, and you're left with 2 x's. And over here, 10x kills the x, and sum of the 10 dies on 2, you're left with a 5, and you just have 15. So something really important to note about rational equations, just to take a pause for a second, you'll notice that with a little bit of manipulation, they're very, very close to being linear or other types of polynomials that we'll see later. There's a very, very close relationship. And you might think to yourself, well, are these two, are they exactly the same? Are they equivalent? And the answer to that question is kind of. They're very close to being equivalent, but there's one important difference, and that's what happens when x is equal to 0. So this is something you have to think about if you go on past pre-calculus to calculus, that there are those holes where the two things are very close, but they're not the same. And that difference is small, but very important. Anyway, from here, we're in pretty standard territory, so because the x is already over here, I'm not going to worry about rearranging it, even though I usually like to have x's on the left. I'm just going to try and get rid of that 15. So I'm going to subtract 15 from this side, which looks weird, but I'm doing that so that I can subtract 15 over there. And as a result, I'm going to end up with a -5 and a 2x, so 1 divide out 2, and to get -5/2 as our value for x, where if you want to check this, you can. It's pretty straightforward. You plug that in there. It's just a little bit funkier in terms of how the numbers chase around, but you will end up getting that as your answer. That our solution set here is, I have 5, so turning into deltas, I have to be more careful. Negative 5 halves, just like we saw. And so far, we've had equations that have a single solution, because, well, for where we are with the algebra we know, with the functions and equations, keep saying function, can't get too ahead of myself. But with the types of equalities that we've seen so far, well, they're kind of only interesting if we have one way that they can go. And we're going to talk about how these things can work, how we can classify these things a bit more broadly in terms of the types of equalities we can see. That's what we'll get next.